Welcome back. In the last session, we covered up to problem number 12. Now let's see problem number 13. The circuit shown in figure is that of what? The circuit is given. This is what is minus and plus. This is VI. This is R2, then R1. Remember, what is this feedback? Now this is in positive feedback, not in negative feedback. If it is in positive feedback, we cannot use virtual ground concept. Then it is nothing but a comparator. When this is what is a comparator, then when you give a sine wave, then the sine wave will be converted into square wave, right? Then your output voltage will be either plus Vset or minus Vset. Therefore, it is not non-inverting amplifier, that is for sure. That is true only for negative feedback amplifier. It is not inverting amplifier. It is not oscillator. It is sine to square wave converter. Therefore, you can say Schmitt trigger, because this is in positive feedback. If this is in positive feedback, when you apply sine wave here, then you will get square wave. You will get square wave. Okay. Therefore, this is Schmitt trigger with common switching point. Okay. Done. Now, problem number 14. An ideal op amp has an ideal what? Voltage control current source. Remember, your op amp is voltage amplifier. That's what people say. This is V1, this is V2, this is V0. If I say this is ideal, because our input impedance Ri is infinity, your output impedance R0 0. Therefore, this is nothing but your voltage amplifier. When I say voltage amplifier, then this is nothing but input voltage. Input voltage will control your output voltage. Therefore, voltage controlled voltage source. Voltage controlled voltage source. Right? Your input voltage will control your output voltage. That is what is called. Therefore, what is the answer? Here the answer. Here for 13th, answer is D. For 14th one, answer is B. After this, we will see problem number 15. The circuit in the figure is Now, is asking what type of filter it is. Okay, for filter actions, when frequency is equal to 0, what is that? DC. Then what is your output? For a DC, this is open, this is open, there is no current entering into op amp, the VI will come here. Therefore, what is your V0? V0 is nothing but VI. Now, when frequency is infinity, this is short circuit, this is short circuit, right? Therefore, now, when this is short circuit, this is what is 0, your output voltage will be 0. Therefore, what does that mean? Frequency and your V0 by Vi, or what it may be, your V0 by Vi, at low frequency, V0 by Vi is 1, high frequency, that is what is 0. Therefore, this is nothing but low pass filter. Therefore, what is the answer? Answer is low pass filter, which is A. Now, problem number 16. The circuit shown is low pass filter with something, high pass filter with something, low pass filter something, high pass with something. What is the something? 3 dB frequency, right? How to get the 3 dB frequency and then what type of filter? You will see. This is what is your capacitor, resistor, and this is simply resistor, okay? And this is your V0. This is what your Vi. This is C, and then R1, and this is R2. Okay, let's see what type of filter, then we will see what is the cutoff frequency. Okay, for a DC, F is equal to 0. This is DC. Then for a DC it is open, then it is floating, then the 0 will come here, then output is 0. Then when F is equal to infinity, this is nothing but AC operation, right? Very high frequency, short circuit, then you will have V0 which is function of Vi. Therefore, what is this? This is nothing but your high pass filter. This is what is your V0 by Vi. This is high pass filter. But what is cutoff frequency? We have two options with high pass filter, right? Therefore, we need to find the cutoff frequency. For that, we need to have the transfer function. Can I call this as Z2? And let me call this as Z1. Then what is your voltage gain? Your voltage gain V0 by Vi is equal to minus Z2 divided by Z1. What is Z2? Minus R2 divided by, what is Z1? R1 plus 1 by SC. If you do that, you will get minus SCR2 divided by 1 plus SCR1. Therefore, if you take Bode plot, your Bode plot is nothing but, this is the frequency, you have a 0 at 0 and you have a pole at particular frequency. According to Bode plot, this is what is your minus 1 by R, this pole frequency. This is what your pole. Pole is nothing but 1 by R1 C. And this is what is your 0. 0 is at 0 frequency. Therefore, this is what is plus 20 dB per decade. This is nothing but your high pass filter, according to Bode plot. Therefore, what is your pole frequency? This is nothing but your lower cutoff frequency or F3 dB frequency. F3 dB or your lower cutoff frequency is equal to 1 by 2 pi. This is radians per second. But we want frequency. If you want frequency or omega, anything, 1 by 2 pi R1 into C, hertz. But what is the option? Options are radians per second, right? Fine. Therefore, answer is 1 by R1 into C. What is the answer? Answer is B. Using Bode plot. In the circuit shown, the op-amp has finite input impedance, infinite voltage gain and zero input offset voltage. The output voltage will be. Given that this is I1 and this is I2. Okay, if you observe clearly, let us say if you take ideal op-amp, completely ideal op-amp, if you take completely ideal op-amp where just few things, Ri is infinity, your differential gain is infinity, okay, and offset is 0, etc. This is what is enough. But you know whatever he has given here, somewhat practical. Okay, what are maybe for this, if you take the same circuit, minus plus, your virtual ground concept is valid. This is your V0 and this is R2, this is R1 ground. If this is the case, what is your output? Right? R is infinite. There is no current entering into op-amp. This is what is 0. Then this is what is 0 and this is also 0. There is no current from this, there is no current from this, then there is no current from this, therefore your V0 is equal to 0. Your V0 is 0. Okay, now, but if you take practical op-amp, that's what? The op-amp what he has given where practical op-amp, right? Where now Ri is not infinity, it is finite, but AD is infinity, and then offset is 0. That is what he told, right? Then what is your V0? This is minus, this is plus. This is your V0 and this is what is your current and this is what is your R1, R2. But now remember, this is your I1, current entering into your op-amp, and this is what is your I2. What it may be, there is some current. Then if you apply, right, because your AD is infinity, since AD, your differential gain is infinity, virtual ground concept is valid, your VD is also infinite, 0. If VD is 0, then this is 0, this is also 0. If this is 0, this is also 0, there is no current which is what is flowing through it. But there is a current which is entering into your op-amp, right? That is because of what? That is what is because of almost 0, therefore it is having input impedance and this is what is your current. Actually your I1 is nothing but minus I2, what it may be. Then when this is what is 0, where is it coming from? Where is it I1 coming from? This is not from this. It has to come from this only, right? The I1 is coming from this. That is what your I1. And this is 0. Therefore tell me what is your I1? Apply nodal analysis. Simply that is nothing but what? No need to apply nodal analysis. Therefore that I1, therefore the I1 is equal to what? V0 minus 0 divided by this voltage minus this voltage divided by R2. Therefore, what is your V0? V0 is equal to your I1 into R2. That is what? It is not 0. How much is the current which is entering into your op-amp into R2? That much will be your voltage. That could be very, very small. Okay. What is the answer? Your answer is C. Take it. This is I1. Okay. With this I can say problems are over. Okay. Problems are over for level 2. Okay. We will see you in the next sessions. Thank you.